Good afternoon, everyone. I'm Jeremy Simon with 3D Universe, and I'm very pleased to welcome you to this session. This is a part of our ongoing series called 3D Printing in the Workplace and STEM Education. And this session is about crowdsourced 3D printing for the COVID-19 pandemic. So I will go ahead and get started here. I do want to invite those watching to feel free to use the Q&A panel to ask questions. You should have that in your toolbar within the Zoom application. So you can click on Q&A and just type your questions in there, and we'll take some time to address all those questions towards the end of the session. So I'm Jeremy Simon, as I said. That's me there on the left, wearing some of the PPE we'll be talking about today. I'm the founder and CEO of 3D Universe, and I'm also a co-founder of the Enable volunteer community. And I'm a 3D printing enthusiast. I just love this stuff. So I've really been doing a lot of work with the 3D printing of PPE that we'll talk about today, and working with a very talented group of individuals, one of whom is with me today, who I'll introduce momentarily. And my email address and phone number are there. So feel free to reach out if you have questions after the session. Or if you'd like to talk further about this. I'm happy to work with any of you. I also want to introduce Peter Cifiletto, who is with me as a joint panelist today. He is the CEO of PVS Process Equipment for 18 years, and he's a pneumatic conveying and air filtration specialist. Pete, let's go ahead and get you on video here. I'll ask you to start the video and get you unmuted. There we go. Thanks for joining, Pete. And I've got his email there too, so you can reach out directly to Pete as well. So I'm going to go through some slides here. I'm going to have Pete jump in towards the end and share some of the work he's been doing with us on the PPE stuff that we'll be talking about specifically in the realm of masks, which we'll get to shortly. But first, we're going to go through some of the other basics. So to provide a little context here, the situation of PPE, at least in the US, which is what this chart relates to, is pretty dire, unfortunately. As you can see, there are extreme shortages happening. According to this, we've got over 60% of medical institutions showing that they have less than a 1-week supply of N95 masks, and the rest of the items on this list are showing similar trends. It looks like about 90% of those same organizations have less than a 2-week supply. So it's just really a serious situation. You've got medical workers on the front lines dealing with patients day in and day out, trying to keep us safe, and they don't have the equipment they need to keep themselves protected. So it's a pretty serious situation. And so the question comes up, can 3D printing help? I'm not sure it's exactly an easy answer. I would tend to say, yes, 3D printing can help, but it's not black and white. There are a lot of considerations. We're going to talk about some of those today. If you've looked at any of the news, you will see that there's a lot of this going on already, right? There's a lot of people who are producing 3D printed PPE. There's news articles about it all the time. And so clearly there's a lot of this going on, but we want to make sure that we kind of point you in a direction where you can do this effectively and do it in a way that's relatively safe and not going to add risk unnecessarily. There are people out there who have argued that 3D printing PPE is dangerous and that it should not be done, and that basically puts people at more risk than they would be at otherwise. I don't personally agree with that. I think there are definitely risks to take into consideration. Most of those risks deal with kind of knowing what you're doing, making sure that you have your 3D printer properly calibrated, and that the items you're producing are of good quality, and that they are being handled in a way that makes sure that you're not exposing them to anything in the way of a virus, and that they're sanitized before delivering, etc. But as long as you take these sorts of reasonable precautions, we have to keep in mind the situation we're in. This is a really serious situation. Again, we've got these medical workers that have nothing. They have no masks. They have, no face shields in some cases, and they're having to deal with patients. I actually have weekly Zoom calls with members of my family. It's been a nice way to stay in touch as we've all been stuck indoors. And I've got a number of doctors in my family who I talk to on a weekly basis, and several of them are having to still see patients who are exposed to the coronavirus. And they're being issued masks that they have to, where they might have one mask that they have to use for a week and that sort of thing, which is certainly far from ideal. And so we have to keep in mind when we talk about 3D printing PPE, that it's a given that this is not an ideal situation, but we are not in an ideal situation. We are in a very serious situation. So the question really is, can we produce things with our 3D printers that are substantially better than nothing, which is what a lot of medical professionals are stuck with? And I would argue that the answer to that is yes. So if you educate yourself and you pick the right designs that have been well vetted, and you print them in a way that you're producing good quality prints and they're being handled properly, I think you can be in a position to help people. And there are a lot of people out there with 3D printers, so we can have an impact through our community. One of the sites that I'll point your attention to, as I mentioned, you want to make sure that you're using solutions that have been well vetted. The NIH, the National Institute of Health, has created a site, which you see the URL for at the bottom of the page here. And by the way, we will be sharing the slides from this presentation after the fact, so you'll have access to all this. This site provides a kind of a curated collection. As you can see at the top left there, it says reviewed for clinical use. So this is a collection of designs that they have reviewed and they have found to be suitable for use in clinical situations. So I would say this is a really good starting point. As you can see, there are things here like face shields. There are these ear savers or surgical mask tension relievers, if you will, and even a mask, which we're going to talk about more today. There is the mask shown in the lower left there, the second in from the left on the bottom row is the first FDA approved mask. That's designed for being printed on pretty high-end kinds of printers, though, like SLS and things like multi-jet fusion, things that most of us don't have access to. So in a short while, we're going to be talking about a mask design that we've been working on, Pete, myself, and quite a few other skilled individuals, that we hope to fill a gap there, a mask that can be printed on FDM printers that has been well vetted by medical professionals. So let's start with the easier stuff. One of the things that you can do to put your 3D printer to use, I would say with very low risk, is producing these surgical mask tension release straps, which are often referred to as ear savers. These are very easy to print. You can print them in a wide range of materials. If you want, you can print them in something flexible like a TPU, but you don't need to because it's such a thin part. You could print it in a standard material like PLA and it'll still be able to flex enough because it's being printed so thin. And so these are very easy to print. As you can see here, using an Ultimaker S5, you'd be able to print these. How many do I have here? Looks like 5 at a time. And it would take about 3 hours and 20 minutes to print 10 of these. So very efficient, doesn't use a lot of material. As you can see here, 42 grams of material at a total cost of $2.79. That's based on the Ultimaker brand of material. You can certainly find less expensive material, which would cut that cost down even more. So these are very easy and inexpensive to produce. And they're relatively safe because, you know, as you can see how they're worn, this would be on the back of the head. So it's not likely to be exposed directly to the virus. So this is something that can be produced with a lot less concern in terms of needing to take all of those extra precautions. So this is something that you can produce that, medical professionals that are having to wear masks all day long will tell you that it can be very uncomfortable. And one of the reasons is those surgical type masks that go around the ears can put a lot of strain on the ears, and it can start to, cause some discomfort. And so these can help quite a bit. Another thing that you can look at printing is face shields, which I think are probably one of the most effective things you can do. And the reason I say that is because it's a nice middle ground in my mind, something that doesn't have the same level of risk or concern that something like a respirator mask that we'll be looking at shortly might have. But at the same time, it's something that provides a very good level of protection. It might be that, a medical professional has a mask available, but this provides a great extra barrier, especially in the case of something like the coronavirus, because the primary way that is spread is through tiny droplets that are exposing somebody either by going into the nose or the mouth or the eyes. And that's why these face shields, are so nice, because they cover the whole face, including the eyes. Now, there are a number of face shield designs out there that are very popular, including one by Prusa which are designed where they have kind of an opening at the top. In fact, I'll go back to this previous slide. You can see some of those here in the upper left, the second and third one in on the upper row, and then over towards the right a little further, the one with the orange components there with the flag. Those are nice designs because they print really quickly, because they've been designed to use minimal material and print very quickly. My concern with those would be that opening that's on the top where you wear this on the head. That area in front of where it attaches to your head is open. And so if a medical professional is wearing one of those and they lean forward, there's an open path where something could enter in and get access to their face. So the one I've been printing, and what I would suggest that you look at, is the one on the upper right here, which is the IC3D Budman face shield. And that one is, I'll go back to the slide I was on here. It's a completely enclosed visor on the top. So once you connect the face shield, the plastic sheet to it, you've got a fully enclosed kind of an area, even if that medical professional is to bend forward. These are very easy to print. As you can see here, you can print one of these in less than 2 hours, depending on your settings. You could even get that down further. The print job that I'm showing there on the screenshot is done with a 0.4 millimeter nozzle. You could easily print this with a 0.8 millimeter nozzle or even a larger one and get that print down by half or less. So there's a lot you could do to adjust your settings and your setup to get these printed even more quickly. And they're very easy to print because they lay flat on the bed, so not a challenging print at all. And you can just kind of crank these out. You can have one print job running right after another. On a large printer like the S5 that I'm showing here, you could easily do 2 at a time at least. And you can just churn them out very easily. I've already produced over 200 of these here with our printers, and you can make a dent with something like this. The other nice thing about the Budman design is that there is a source for getting the plastic sheets that are needed for these. Now you can use various types of materials, like what they're showing in the photo there is, I think, just a sheet protector, and you can punch holes in it and you can use something like that. But as you can see, it's not perfectly transparent. So ideally you'd use something like a clear PETG or polycarbonate sheet where it's more, perfectly clear. There's a site, which I didn't get it in here, but there's a site that I'll share the link to. It's papergala.com. Papergala, Gala, and it's a company that has retooled their manufacturing actually to address this need, where they are now producing pre-cut plastic sheets specifically for this design, for the Budman design. So you can buy these 10 packs of pre-cut, pre-hole punched sheets. I think they're selling them for about $18 and some cents. That can add up if you're looking to make these in huge quantities. So if you're making a lot of these, it might be better to try to source your own raw material, but it is one easy option for you to get the sheets for this particular design. So again, we'll share that link as part of the follow-up materials from this presentation. But the face shields are a really nice, effective solution, something that anyone can produce. Those plastic shields that are sold by Paper Gala, when you receive them, they're packaged in sets of 10, and each sheet has a protective film on it. So what we've been doing is we're just printing the visors, and we put on the elastic straps that they show you in the instructions, and we're using little barrel lock connectors, which, let's see, I have one here as an example. So you can use these little barrel lock connectors to put on the elastic strap to make them easily adjustable, and a little foam padding on the inside for comfort. And we would just assemble the actual visors like this and send them to the medical facilities, and then separately send them the plastic sheets, still in the packaging, still with that protective coating on them, so they can take that protective cover off and put them on at their facility to make sure that they haven't been handled by anybody and that they're still well sanitized. So that's a nice option to consider. And then we get into respirator masks. Now this is, I think, the most interesting area and the most interesting opportunity, but this is also the one that raises some concerns. You want to make sure that you're doing it right, and that means having the right design as well as the right process behind it. And so, as I said, I've been working with a really extraordinary team of individuals, which includes Pete, who's with me today, as well as quite a few others. A lot of them are out of the University at Buffalo, out in New York, along with quite a few medical professionals and other industry experts. It's quite a talented team. And so we have a group of people that has been meeting regularly. We're meeting every 2 days. We've had, I think, 23 meetings or so already. And we've been working on these designs for a 3D printable respirator mask that has been well vetted by the medical professionals. It's going through extensive testing, both in terms of the fit quality on the face, as well as the filtration effectiveness. And we're still gathering all of those results and working on publishing them. But so far, the results of our testing have been very positive. In fact, the effectiveness of the filtration that we're using, which we'll talk about momentarily here, has been found to be 97% effective compared to an N95 mask, which of course is 95%. So a comparable level of filtration quality. And the face fit has found to be very good because this is a mask that we're printing in TPU, which is a nice flexible material. It's more challenging to print, so that introduces some challenges, but if you get your printer optimized properly for TPU, this creates a really nice flexible mask that fits well to the face. And we're actually developing it in quite a few different sizes. Right now, the current version, the version 1.0 that you see in this picture, is being offered in 5 sizes. We're adding in a 6 size that's even smaller. And some of the future designs, we're going to try to consolidate that down to a smaller number of sizes that would fit, a pretty broad range of people. But a lot of work has gone into this design. It was based initially on a design that's known as the Montana mask, which was created by a couple of medical professionals in Montana. And their design was quite good, but we found some opportunities to make improvements. First of all, we're printing it in that flexible material, which we feel makes a significant improvement in terms of the fit on the face. We also adjusted the scaling to provide a further better fit because we extended it vertically in the terms of the way it's sitting on the bed there, so that it has more depth, which allows it to fit better on the face, doesn't push down as much on the nose as it was otherwise, gives you a little bit more room in front of the mouth. And then we also made some adjustments to that center area where the filter goes in. We added that reinforcement grid, which is both in front of the filters and behind the filters. It gets, here's one of these that you can see. So there's the mask itself. On the inside, there's a filter insert that gets printed in a rigid material like PLA, and you push that in over your filtration material, and it holds it nice and snugly in place. And that reinforcement grid is holding it from both sides, so that if a medical professional is working in a crowded room and somebody knocks them, you don't have to worry about them pushing that filament, the filter out easily. It's very nicely held in place from both sides. So we've made some nice improvements like that. And you can get more information about this on our blog site, 3duniverse.org. We're doing regular updates there as this design progresses. There's all kinds of instructions, the links that you need to get to the STL files, assembly materials, and where you can find them. For the filtration material, now we're using a MERV 15 rated filtration material, which meets or exceeds that material that's used in N95 masks. And we're using 2 layers of that filter material, which is important. So you have a double layer of that filter material. And the reason we chose this MERV 15 filter material, which was actually a recommendation from Pete, who's with me today, is that it's easily obtainable through sources like McMaster Carr. They have something it's actually a bag air filter. It's this large frame that has multiple large bags on it made out of this filter material. And you can get one of these, big bag filter units and then basically take it apart and cut these big bags into sheets and cut those down into individual squares that you need for this. So you can get quite a lot, quite a few 100 sheets easily, squares that is, out of one of these bag filters, which you can get for, I think it was around $50 some from McMaster Carr. So pretty affordable. And so we found that to be a very effective and easy to obtain filtration option, whereas a lot of the other filter materials are in short supply. And that's why we went with that. Now, Pete here has been working on a new version, which we are looking forward to releasing soon. And Pete, I wonder if you want to jump in and talk about some of the improvements of what makes this version 2 design unique and the features that it offers compared to the version 1. I had your video turned off, so go ahead and turn your video back on for us there. And go ahead and talk to us about what's part of this version 2 design.
Sure. The video, let me see if I can get that going here. Anyway, you don't need to see me. The video, or the V2 mask, is interesting in a couple of regards. Number one, we eliminate the need to have a panel filter removable from the inside. I think in talking with some of the medical professionals, we found that there was concern with having their hands inside of a mask itself. The second part of it, which was interesting, is it eliminated the need to have any cutting. We found a HEPA-based cartridge filter that we could slide into the mask with a rubber seal that once it a uniform seal all the way around, so we wouldn't have any issues of seal. We've made some modifications to the actual the face seal that sits on your face. The profile has been cut a little bit differently. You'll notice this mask is a little bit wider side to side than the V1 mask, and that's so it will sit on your cheeks, not pushing a little more into your face. To get rid of the pinch that you'll feel when you put on either an N95 or another mask where you become a mouth breather inside the mask. And then, we added a cap on the outside of the mask. Again, all in TPU, so a very flexible material, very easy to form fit on your face. But the cover allows for nobody to be rolled out in 3 sizes, a small, medium, and a large. And I think some of the other one of the unique features will be the idea that we can actually customize this mask using a few dimensions from a person's face to be able to scale the mask to meet their needs. So that's about what I know so far. It's about as far as we've gotten.
Yeah, it's looking good so far. Pete's been doing a lot of work on the modeling of this, and I'm thrilled to see how it's coming together. And we're also working on an adapter for this, so that for those people that might not be able to source these particular circular HEPA cartridges, we're going to give an alternative option where you can use that same filter material I mentioned before. And we're going to use a different size, though, where we give you more. It's going to have more of a surface area for that filter material to improve the breathability. Because what's nice about these HEPA cartridges that Pete showed you is that filter material inside is, it's folded back and forth many times, and that gives you a huge amount of surface area compared to the size of the actual outer unit. So that helps breathability. It makes it a lot easier to breathe through. And so we're going to make that a second option for this design, where if you don't have access to that HEPA filter, you'll still be able to use the sheet filter material, but we're going to give you more surface area on that so that you have an easier time breathing. The version 1, I'll mention, by the way, with 2 sheets of that filter material in there, it's not bad. You can breathe through it easily enough. Medical professionals who have tested it have said that it's fairly comparable to wearing an N95 mask, which isn't all that comfortable, if you're wearing it for a long period of time, but it's not significantly worse. But we think we can improve on that significantly with this new design. Let's see. So those are the items I wanted to share. Now, I don't know if anyone has, let me go back to this. So we've got some contact information there and some sites where, part of this work is being done through the Enable volunteer community. We have a lot of volunteers who are working on this, and we'll be sharing, information about these solutions as they continue to develop through enablingthefuture.org. As I said, you can also check our blog at 3duniverse.org. We're constantly posting updates there as well. And feel free to reach out to us by email, if you have questions and would like to discuss further. Let me just switch over and see. I don't know if we've had anything come in on the Q&A. I don't think I saw anything come in yet. No, Q&A is clear. So I'm going to give it just another moment before we wrap up here. If you have any questions, please go ahead and type them in at the Q&A panel now. Pete, anything else that you cared to add from, the stuff that I went over that I didn't touch on? Did I miss anything?
No, I thought you covered pretty much everything. I think this mass conversation of all the pieces that the e-enable community and the 3D printing community can develop, the ability to mass customize a product like a mask that fits somebody's face. It's the only technology out there that we can deploy. Whereas anything like injection molding or things like that would be a one-size-fits-all type of approach. 3D are some of the unique customizations that require to form fitting PPE to somebody's face or other PPE, whether it's face masks or other things down the road. There is a to fit this space. I think it's a huge opportunity.
Yeah, yeah. And the other thing I want to point out is I mentioned earlier that, the masks have risks associated with them, but I think most of those risks have to do with the process. In other words, making sure that you are printing them in a way where the quality is good and that they're being checked over to make sure that they are consistent quality and that they're being handled properly, and all of those kind of surrounding considerations. What we're doing to address that is, I think, quite unique. We're actually working on a process where we'll have centralized collection so that people will be able to, if people who want to print these will be able to send them out. Pete's actually coordinating this out in New York. You'll be able to send these to his facility where they have a team that's actually going to do quality checks to check over the print quality, check to make sure there's no porosity and that they have a good seal in terms of, the body of the mask itself. They're going to, check over the assembly, make sure everything is done properly and consistently. They are going to do as much sanitization as possible to make sure that these are clean when they go out. They're going to make sure they're properly packaged and then handle the distribution from there. So I think having that kind of centralized collection and quality assurance is really important because, people with, people with different 3D printers are going to get different results. As part of the Enable community, I've done a lot of work where people print, components for these prosthetic hands and arms that we make. And I've had a lot of people sending those parts to me. And so I've had an opportunity to see the kind of print quality that different people get. And there's a big, variety. Some of them look fantastic. Others, are just not, even acceptable because some printers just aren't tuned as well as others. And so having somebody, I think, involved in QA and checking the quality is important. So that's something else that we're introducing here. So now we do have questions flowing in. I'd like to go through some of these in the Q&A. We have a question: are there any materials that you should not use for face masks as far as the 3D printing parts? So, I would say that our mask is designed specifically for TPU. And so the best thing to do is just stick to that because that's the one we're testing. That's the one that we're most comfortable with. Are there other materials that you shouldn't use? Yeah, probably. I'm not sure I can give you the specific list of what those are. I mean, I probably wouldn't choose something like ABS myself, being a plastic that's maybe has a little bit more toxicity and that sort of thing to it, being derived from oil products and that sort of thing. I don't know if that's something I'd want to wear on my face. Some people have allergies to certain types of materials, so you'd want to avoid any materials that might cause that kind of an allergic reaction. But I don't know, I don't have any other specifics in mind that I would specifically recommend against. I think the key thing is here that we want that flexibility that TPU offers, because that gives you a much better fit. We did initially do a lot of testing and printing this mask design using more readily available materials like PLA, and you can do it. We actually worked on doing a sort of a gasket, flexible gasket lining around the edge of the mask to give a little bit of a better fit on the face, but still the feedback was that the fit wasn't nearly as good as what you get with the TPU mask. So that would be our recommendation. Pete, can you think of any other materials or anything that you would want to steer clear of?
No, you nailed ABS in terms of its material. I know we've had some people experiment with other flexible features had nearly as much success as what we have found with TPU. I think the TPU has been the best material for us so far.
Yeah. And it does print fairly well once you get the settings right. And we are also doing a lot of work to include that in our documentation. We're sharing all the settings that we've found to work well for our design across different types of printers, and we'll continue to add to that data as we go. So we're going to do our best to give you the guidance that you need to really set up your printer properly for printing that material. So another question is, what material do you use to print the face shields? I think that's one of the nice things about the face shields is you can use pretty much whatever material you want. PLA is probably the most common. But again, I mean, it's just what you're printing is this. You're printing just it's a visor that goes on the head. It's not under a lot of stress. It doesn't need to flex really. It doesn't really have a lot of physical requirements. It's simply there to hold the plastic sheet in place. So you could use really whatever you like printing in. Some people like PLA, some people like PETG, tough PLA. I would say those three are the most popular: PLA, tough PLA, and PETG, because those are all pretty easy to print with. They're pretty safe. They're pretty inexpensive, widely available. Those are the three that are most common. But if you wanted to use a nylon or a copolyester, you could use pretty much anything for those face shields. Again, ideally, you're going to line the face shield with some kind of, I'm using an adhesive foam padding here, so the material itself isn't even touching the skin, and that's why it really doesn't matter what you use. Okay, next question is regarding the circular HEPA filter. What is the product code on McMaster? I don't even know if that one is available on McMaster. Do you know, Pete?
Not on McMaster. It's not on McMaster yet. We are working with Amazon store to get them up on Amazon, and we're working with Granger to get their stock reapplied.
Excellent.
McMaster has not been carrying it, but that's where we're working at. The problem has been, like with everybody else, the rush for PPE. Those circular filters. Anybody who wanted to have stock in those filters here at PVS, we have 1,000 of the filters in stock, and the manufacturer is committed to about 1,000 a week. So as McMaster though.
Yeah. Okay. So, and we're going to be sharing all of that in our documentation and the follow-ups for this. So we'll point you to the site where we have all the docs for this design, and that'll include specific links to these materials. So as soon as we release this version 2 design, we will also share links with exactly where you can get that HEPA cartridge. So we will share those details in the near future. That design has not been released yet. We're still working on the final modeling and testing. So we'll need a little bit more time on that one. Okay, next question up here. Would it be easier to do injection molding versus 3D printing for masks? That's an excellent question, and it is something that we are talking about and exploring. So far, it hasn't really panned out for a variety of reasons. Number one is that setting up a mold for injection molding is quite expensive, and you need to make sure that you have the design really well locked in before you invest in that. But once you do have that, then you need to make sure that you can produce them in the right kind of materials, in the quantities that are needed, in the different sizes, et cetera. So for right now, you know, our focus is on 3D printing because we're really still in a prototyping phase. I mean, we've released our version 1, but we're still rapidly iterating on that. We're coming up with new and improved versions of the design, and it's likely that that's going to continue. So we don't want to go and invest in an injection mold knowing that our design is likely going to change in a couple of weeks or a few weeks. So that's one reason that we have not gone down the injection molding route. Another reason is having to do with customization. You know, Pete talked about this. One of the really powerful aspects of 3D printing is the ability to do custom items. So we're releasing this design in a number of different sort of preset sizes. But after that, we're going to then move further into doing custom fit masks. So, you know, our plan is that after we release the base version, which version 2, as Pete said, will be available in 3 standard sizes. If someone finds that those standard sizes don't work quite well for them, or if they just want a really, you know, fit like a glove custom mask, we're going to give them the ability to actually do custom measurements on their face in specific ways that we'll guide them on. And we can then enter that in and create a custom model that is designed specifically for that one person's face and print that out. And because that's where the 3D printing advantage really comes into play, the ability to do these one-off prints that are really specific to one individual. And you just couldn't do that with injection molding. Okay, another question here. Could you use a silicone mold to make masks by 3D printing one and then making a mold and making it that way? The answer is yes, as far as I'm aware, though it's not something I have done or tested or focused on. I think the same is true for Pete. You know, we've just been so busy focusing on the design and the 3D printing process that we are currently focused on. I do know that we have at least one volunteer in the e-Enable community by the name of Nate Monroe, who has done some testing with that in terms of using, you know, 3D printing a mold and then injecting silicone into that. And it looked like he was getting decent results. I don't have a lot of detail though on where he is in that process. So that would be something that we might be able to follow up on and get more detail. My preliminary sort of answer would be, yes, I believe something like that is possible. I just don't know how well it works or how easy it is to work with because I haven't done a lot of work with it myself. Next question here is, I've heard you can use coffee filters for filter materials. Is that true? Pete, I think you've got more expertise on the filtration, so take that one.
In the world of is that true, is a coffee filter better than a scarf? Yes. But when you start to look down at the submicron particle size of something like to a 0.2 or a 0.3 micron particle, a coffee filter just is not efficient. A coffee filter, a sheet, those types of things are good for protecting droplets that come out of your mouth. They'll protect you from virus. The best filtration, or the most recommended filtration, is an N95 style mask or something is rated for 95%, greater than 95%, and then HEPA would be your ultimate. But I would not recommend a coffee filter if you're trying to keep yourself from getting the virus itself.
Yeah, thanks for that. We're having some audio issues here. I think most of that came through though. I do want to just point out, because one of the other things I've seen in a lot of the forums and people talking about this is people talking about the actual size of the coronavirus molecules, which they've said are in the neighborhood of 60 to 140 microns, which is pretty small. You're talking about 0.06, 0.06 microns to 0.14 microns. Now Pete mentioned, that a lot of these filters are developed like N95. They talk about 0.2 to 0.3 micron size. And the reason that difference is important is because you need to keep in mind, you're not really talking about the size of the coronavirus molecule itself. You're talking about the size of the liquid droplets that it's being carried on. That's what the real concern is, because that's how it's being transmitted. So those liquid droplets are, larger than the coronavirus molecule itself. And that's what we really want to make sure these filters can handle. But what Pete said is absolutely true. You really want to be dealing with something that's got that N95 or higher rating, and the MERV 15 rating. It's just a different rating scale, but it is at least as effective in that sense as an N95 rating. Okay, and then we have one other question here. Will there be a centralized location for the face shields too? How do you find out where to send them? So that hasn't been our particular focus, but there are some good options for you, and I will include these in the follow-up links. There's one site, and I'm going from memory here. I hope I get this right. I think it's getusppe.org. I might not have the URL right, so I will make sure to share the correct URL in the follow-up here. But that is one of a number of sites out there that is basically a gathering point where you can go to people that need PPE can go there to request it, and people who are making PPE can go there to see who has been requesting it and where they can send them. So sites like that, and I'm sorry, I didn't have the URLs for that in here, but I will find those and share them in the follow-ups. There are sites like that where they are gathering these needs and sort of giving you those locations of where you can send them. But you can also check in your local community. Feel free to reach out to local medical institutions, and don't limit it to just the hospitals. Other clinics, doctors' offices, and elderly homes are also at great risk, and places like that could also use help getting things like this. So feel free to reach out to places like that in your community and find out where you can help locally, because that's what's great about this community effort, is that we have people all over doing this. So if all of us are kind of doing this in our local areas and kind of focusing on the people locally that need help, then we can have a pretty broad impact through that approach. Okay, well, I'm not seeing any other questions at this point, so I think we'll go ahead and bring this to a wrap, but I want to invite you all to send your questions to us if you have them. You can use my email address here, jeremy@3duniverse.org, or our info@3duniverse.org address, which goes to a broader team, and we'll be happy to address any questions that come up after the fact. We will be sharing a recording of this, as well as the slides and those relevant links that we've talked about today. So stay tuned to that page that we showed you back in the beginning, which I'll just run back to that real quick here. Whoops, get back to my presentation screen here. So tinyurl.com/3du-webinar. That's the page that will have all of the follow-up content, the recordings, the links, everything you need will be there. So check back on that site for that information. I want to thank Peter for joining me for this. It was great to have you, and thank you for all the work you're doing on this.
Thank you.
All right. Thanks, everyone. Thanks for joining. Bye-bye.